Welcome everyone. There is some technology glitches that I encountered. Normally, well prepared uh, presentation that we're going to have it, and it's wonderful to see. Fantastic audiences joining, and we have over 300 participants who's expected to join. And we've been having webinar since last Thursday. Thursday, we spoke about on the video management, and we had a very interesting session on this Saturday, was basically targeting on audience to understand the enhancement of early fire detection. So today, Saturday, 9th October, we are starting at 11 o'clock. We have a wonderful speaker today. Why did we pick up this topic? The reason is when you see the screen here, these are some of the statistics that we are able to pull out. If you look at annual fire incident that is happening across India, so as per the NCRB reports, almost 18 to 20,000 fire accident annually reported. And these are, when I say reported, these are the reported on record. And we get almost 800 fire calls per day all over India, 800 fire calls. So NCRB talks about loss of life, almost 2,000 deaths per year. So this is considerably from the industrial and commercial sector. So due to factors like inadequate fire safety measures and delay in emergency responses. So what are the economic losses that we we face it? So it's more than 100 crores annually. So these losses come from damage of property, machinery. So another major damage that we see, the production. Well, if there is a fire in the industry, entire production is stopped. The loss of the production is not calculated. So this hundreds of crores is only on the loss of equipment. So common causes, again, electrical short circuits, improper storage of flammable material, and non-compliance with fire safety regulations. So today topic we are very focused on how do you detect and suppress these electrical faults, or basically on electrical panels that we have. So how do you detect in the electrical panel and suppress? So minimize the damage due to fire. So recent fire, when you look at it, Anaj Mandi fire in Delhi, then Visakhapatnam gas detection, gas leakage. So totally 43 people dead in the Delhi fire, and Visakhapatnam almost 10 death, and thousands of people have evacuated due to toxic fire exposure. So basically, why this happens? So the urgent need is to create awareness. So widespread awareness. So today's session again is basically educate and let you know how the fire detection system has progressed in the last couple of years, and what are those advancements. So today's topic is very important for all those people who have joined. Okay, fire safety is not just a critical requirement. It's a proactive measure that saves lives, protects property, and ensures the continuity operations in both industrial and residential and commercial building. So today we are privileged to have Mr. Selvakumar, whom I will introduce in the next slide. So his experience will be fantastic for all the attendants. Okay, so today's session is brought to you in partnership with Agni Controls, whom I know Mr. Balchandar, who is the chairman and managing director of Agni Control, and I always very proud whenever I speak to him, and he is the man in the fire industry, in the early evolution of fire industry. So he was very much active in providing effective fire suppression, fire detection, firefighting in the industrial. So he's one of the champion in Indian fire industry. Mr. Selva is the son of Mr. Balchandar and is a proud son and who's carrying forward the legacy of Mr. Balchandar. So I would like to introduce Mr. Selvakumar. He is a technocrat with more than a decade of experience in core industrial fire protection system, including fire detection, fire alarm, and gas suppression system. He is a certified fire protection specialist from CFPS and NFPA USA, and also he is a member of Institute of Fire Engineers UK. Highly educated, he learned he has also studied case studies in the industrial fire accident, and he's going to present us today about his learning on the advancement of the fire detection. So myself, I've been in the fire industry more than 34 years now, the founder member of FSA, Fire and Security Association of India, founder of Focus, Forum of Critical Utility Services, and also the very actively involved in National Federation of Electrical Safety. So I would take this session forward with Selvakumar. I would like to welcome him. So I've unshared. Selvakumar, over to you. We hopefully have a good session. I'll just remind you to all the participants, please post your question in the Q&A box. Down you can find Q&A box. In the chat box, if you put, it will not go on record. So I would appeal and urge all the participants to put your questions. So the question has to be very relevant to today's topic. Okay. So we'll try and address your questions. And also, if you raise your hand, we will go live and have an interaction with our speaker. So those who would like to talk directly with our speaker, please raise your hand. Put your question in the Q&A box also. Over to Selvakumar.
Yes. A very good morning to one and all who has come here from all parts of the country. Thank you so much. And I will keep this session on how to enhance early fire detection of the fire alarm system. Very short and brief, so that it will be beneficial for everybody. So before going into it, is my screen visible to you? Can you confirm, Mr.
Yeah, we can black patches, but hopefully as we progress, it will not be visible. Now it's a full screen. You can go ahead.
Yeah. All right. So moving forward. So before going into the session, I'll just give a brief introduction about Agni Controls. Mr. Dominic has already given a brief introduction about Agni Controls and our chairman, Mr. Balchandran. Agni Controls was established in the year 1985. Initially, during the 1985, Agni Controls was manufacturing custom-built electrical panels, and fire alarm panels was one of the custom-built product, and that was our venture into the fire industry. As on date, Agni Controls specializes in gas-based fire suppression systems, fire alarm systems, and special application fire detectors. Agni Controls provides its products in the following brands. Balava series, which is for the gas-based fire suppression systems, including CO2, inert, and clean agent. Flooded series, which is our special application detectors, including flame, ember, probe type heat detectors, spark, and gas detectors. DFA, which is an automatic fire suppression system. And finally, Balava mist, which is high pressure and low pressure water mist systems. Agni Controls has its strong presence in the following sectors like oil refineries, power, heavy engineering, automobiles, textile mills, and defense sectors. So these are all just a few, list of clients that we wanted to share. From automobile sector, power generation, heavy engineering, textile mills, and export market. So that was the brief introduction about Agni Controls. Now, without further delay, let us go into today's topic on how to enhance early fire detection capability of the automatic fire alarm system. So should you have any questions, I would recommend you to note down and raise your queries. We'll able to answer the questions later on once the session is complete. So IS 2189 is the Indian standard for fire alarm systems, what we are following in the nation right now. So as per the IS 2189, what does the standard say? It says that no single type of detector is best suitable for all types of fire. So basically, what it suggests is that the designer has to choose the right detector for the right application, and not just smoke detectors for any application. So, and it has to be the mixed type of detector shall be used for effective fire detection capability. So that is what the IS 2189 states. So why do we need mixed type of fire detectors? Well, early fire detection will ensure minimum loss and better control. So in this session, we are going to show the availability of various types of fire detectors: smoke, heat, flame, spark, ember, which are used in the fire detection. So we are going to throw some light on the various types of detectors that are available and which detectors are more suitable for early fire detection to enhance the fire detection capability. So any fire protection involves these four steps: fire prevention and compartmentation, which normally happens in the design stage and the building architectural stage before finalizing the plans. And the second step is to detect the fire in the incipient or the early stage. The third step is the evacuation process to save lives. And four, to fight the fire. So these are the four steps. So now we're going to talk about step two, which is early fire detection. So this session is going to be concentrating on the early fire detection capability of the fire alarm systems. So what is the need for early fire detection? Of course, we all know that when fire is very small, it is easy to extinguish. So this is a small animation that we often show in many of the cases where when the fire has started, here you can see one small fire which is happening in one corner of the room here. And within a few seconds, the fire will start to spread to the entire room, raising a lot of smoke plumes with a lot of toxic gases. And within a few minutes, maybe less than 2 minutes, the entire corridor, not just the room, but the corridor also, if it's not properly protected, will be engulfed in the flame. So fire, when it's very small, and if it's detected early, it is very easy to extinguish. Once it goes beyond control, it's very difficult to contain the fire. So to understand about fire detection, we must understand the basics of fire science. Fire emits energy. Energy is in the form of heat, smoke, and radiations. So the amount of, I mean, the smoke or heat or radiation depends on what fuel source it's burning. So if it's basically a class A fire, which is like wood and ordinary combustible, it's going to be smoke, heat. And when the class B fire, which is flammable liquids and gases, it's going to be radiations, which is going to come out first. So to achieve early fire detection, understand the fire. Fire releases smoke, heat, and flame in any one or in a combination of various sources. Fire can be detected by using either flame, heat, or smoke. So it is very important for us to understand how each detector can detect fire. So this is the basic fire alarm system, which all of you might know. it needs the detector. First of all, the signal initiating devices, detectors, which is connected to a control panel, and signaling devices, which will give the outputs like alarms and operate other gas suppression systems or any systems. So for many of the people who are new to the fire industry, this is a very layman terms of explaining how each type of detector works. So smoke, you can relate it to your the nostril, the nose, where you can sense something burning or some smell, which is charring kind of thing. You can smell. So a smoke detector is similar to that. Probe type heat detector or heat detectors are similar to your skin, wherein you can feel the heat or chillness in your skin. And flame detectors are your like your human eye, which can see a flaming fire at a far distance. So now going into the fire alarm system, I'm just going to show a quick, um, you know, um, flow of the different types of detectors. So smoke detectors have been used in the fire alarm systems and are being used in the fire alarm systems for over several years, and it will still be used. But the problem is that it is suitable only for indoor application, and it requires frequent maintenance and dust proof environment. There are different types of smoke detectors. The most commonly used are the photoelectric smoke detectors, aspiration type smoke detectors, where air is drawn through the tubing and the air quality is sampled, and based on the air quality it confirms if it's a smoke or not. Going on to the heat detector are available based on different technologies. Fixed temperature heat detectors, where the set temperature, when the ambient air temperature reaches the set temperature of the detector responds to a heat. So for example, if you have a 60-degree heat detector and the ambient air reaches or crosses 60-degree, the detector will operate and gives you an alarm. Rate of rise detector, it operates when there's a sudden increase in the temperature. So within a specific time period and the temperature suddenly increases, this detector gives a heat detector alarm. High temperature probe type heat detector. This is also a fixed type of heat detector, but here it contains no electronic components and it's a purely bimetal type of sensor. So the temperature can be used in very high temperature areas, right from 90 degrees up to 400 degrees Celsius. And we have the linear heat sensing cable, where it is a cable with different conductors having a special polymer coating, and based on the set temperature, the conductors come in contact and gives an alarm. Now we have different type of the LHS cables available in the market, including fiber optics also, but we are not going into that right now. Multi-criteria detectors are a combination of several particles like smoke, heat. Nowadays, we also have IR and carbon monoxide, other particles of the flame also integrated into one single detector. And also we have the beam detector. The beam detector is also a type of smoke detector. It is suitable for high roof applications like warehouses and atriums, very huge halls. The problem is that it needs lots of maintenance and a dust-free environment, and the alignment also is a huge challenge during the installation phase. And the advantage of using this beam detector is that a single detector can cover a huge area. So now we're going to talk about the flame detector. So flame detector, as I explained earlier, it captures the radiations coming off from the flaming fire. So there are different radiations coming off from the flame, which is UV and IR. These detectors are suitable for long range covering, and it is one of the fastest methods of detecting a flaming fire. And also, it is immune to false alarms. So here I have a small video which I will just play. If you can just watch this video, I'll pause and I'll continue. So here we have a 50 mm flame and the distance is 6 meters. And you can see all the detectors which are mounted in different angles and different, even the right side, we have different types of detectors. And here, each of the detector has different viewing angles. And within a few seconds, you could see the entire detector is detecting a single source of fire. So for the benefit of others, and if anyone has missed the video, I would like to play the video again. So this is a flame detector, and it works on 24-volt DC, and it can be connected with your existing conventional system, or the addressable system or PLCs through modules. As suggested, it has a long range and a quick flame detection capability. So there are different types of flame detectors: UV detector, IR flame detector, a combination of UV and IR, which is a UV IR flame detector, and triple IR detector or multiband detectors. Now, the UV flame detector. So as the name suggests, it consists of a single UV sensor to detect flame. This detector is very, very quick in detecting a flaming fire. But the challenge is that UV is available in many sources surrounding our atmosphere, like the sun, any welding arcs which is done far away, lightnings, special decorative lamps. Many of these and some machineries also emit ultraviolet radiations. So UV detector detects very fast, but the problem is that it's more prone to false alarms. Next, the IR flame detector consists of a single IR sensor to detect flame. Again, IR is also available in the atmosphere. So whenever there is a heat generated, it emits a considerable amount of IR radiations. So these detectors are more prone to false alarms in cases where there are hot body objects nearby. So for that purpose, a combination of UV and IR detectors sensors are being used in the UV IR flame detector. So as the name suggests, it has a combination of UV and multiple IR sensors to confirm whether it's an actual fire or a false source. So these detectors are suitable for both indoor and outdoor applications. And since there is a multiple sensor confirming a fire, these detectors are more immune to false alarm sources. Finally, the multiband detectors, or the triple IR flame detector, consists of different three types of IR sensors of various bandwidths, and it conforms to the spectral range of the flaming fire. So these detectors are suitable for the outdoor applications and long range distances. For detection capability of more than 50 meters, these detectors are more suitable. And these detectors are extremely immune to false alarm sources. So as explained previously, so this is a small animation where a flaming fire has occurred. And as you can see, the fire emits IR radiations coming off from the bottom and UV radiations coming off from the top of the flame. So these detectors, once it is detected, the detector has operated here. It gives a signal to the main fire alarm control panel, which in turn gives output to the strobe horns or the your fire suppression systems or any logics which is as per the designed logics. So these are the flame detectors. Now coming to the final type of detector which is available is spark or ember detectors. So here I have an image of an ember. So this is not an actual flame. This is a smoldering fire. So the best example of a smoldering fire is the tip of an agarbatti. So here, that is not an actual flame, but these detectors are designed to detect moving smoldering fires on a conveyor, especially on the coal conveyors. So here I have another video for you to show how the ember detectors are detecting the embers. So if you can watch the video. So here we have an incense sticks, which is agarbatti. So as you can see, uh, this person is moving the ember as fast as possible, and these detectors, all the detectors which are connected here, all the detectors are responding to a moving ember. So these detectors are basically designed to operate on a moving smoldering fire, especially on a conveyors. Okay. So just summarizing, flame detectors detect the fire by checking the radiations emitted by the flames, and flame detectors are commonly used in environments where your traditional detectors are not suitable. So this is a small comparison of various types of detectors. On the first column, I have different kind of applications like indoor application, outdoor application, class A fire, which is ordinary combustible material, class C fire, which is electrical equipment, energized electrical equipment, class B fire, which is flammable liquids and gases, long range detection capability, immunity to false alarms, and the response time. And on the first row, we have different types of detectors, which is the smoke detector, heat detector, combination detectors, aspiration detectors, beam detectors, probe type heat detectors, flame detectors, ember detectors. Right. So as you can see, I'm not going to elaborate this table in detail, but you can see that each type of detector has its pros and cons, wherein the flame detector has a unique advantage wherein it can be used indoor, outdoor for class A fire, class B, class C fires, long range detection range capability, immunity to false alarms, and a quicker response time, which makes the flame detector a whole detector with a enhanced fire detection capability. So even though the flame detector is the most quicker method of detecting the flaming fire, the suitable detector has to be chosen for the right application. So there are different types of flame detectors available, and the designer must be very sure in choosing the right detector for the right application. So again, coming back to IS 2189, it can be considered for high ceiling areas, roofs where high value combustible materials are available, and smoke detectors have limitation to use in these areas and open spaces. Flammable liquids like paint, oil storage area require heat or flame detectors. So this is what the standard suggests. So what should be taken into consideration is the angular sensitivity of the flame detector. The flame detector has a wide range of angular sensitivity from 45-degree left, right, up, and down. So which basically forms a 90-degree cone of vision. And so a single detector in this along the optical axis, that is the center point, has a detection capability of more than 30 meters. And a typical coverage area here, just for a reference, I've shown a 25 meter by 25 meter area. where it's a 625 square meter area, can be effectively covered by using just two flame detectors. But the only catch point is that there should be no blind spot. So this is similar to a human eye. If there is a if there is some object which is blocking your view, you cannot see what is behind it. Similar to that, the flame detectors shall have no blind spots while positioning these detectors. So for the benefit of everybody, I have just listed a few applications where the flame detectors are used. Server rooms, data centers, UPS, subfloors, clean rooms, machineries, different types of areas and applications. So for the benefit of everybody, which detector is suitable for which application? For server rooms and data centers, it is a purely indoor area where there is no possibility of any hot works like welding or other things. It is recommended to go with a UV detector, but the preferable choice would be a combination of UV and IR sensor, considering the better immunity to false alarms. These are all some of the factory process areas, high roof areas, and flammable areas. So, like control rooms, UPS rooms, pump houses, engine test heads, battery walls, cotton godowns, warehouses, etc. The best recommended detector would be a UVIR flame detector. Again, factory areas, process areas, explosive atmosphere. So paint rooms, wax mix rooms, thinner rooms, LPG and diesel yards, LPG filling stations, refineries, power plants, paint booths, tank farms, all contain flammable materials, highly flammable material with very high calorific value. So in those kind of atmosphere, it is recommended to go with a flame-proof UVIR flame detector. And there are some specific cases where, as I suggested earlier, where UV and IR is normally emitted by some machineries, like a UV ink printing machine and IR heater ovens. So for that application, the conventional flame detectors cannot be used, and a machinery flame detector shall be used, which is specifically tuned for these kind of applications. And for remote areas, like you have a warehouse very far away from the plant, very remote control station. So, in addition to the flame detector, we have integrated a visual indication or camera system, which can be connected with the fire alarm system, where you can see a video feedback of a fire. And for outdoor applications and critical areas, it is better to go with a triple IR flame detector, like refineries, power plants, tank farms, high roof atriums, warehouses, etc. So fire needs to be identified at its initial stage within a few seconds rather. So otherwise, as I explained in the animation previously, once it grows, it's very, very difficult to contain. So why only smoke detectors? Use special application flame detectors to enhance the detection capability. So when we're talking about enhancing flame detection, it is only fair for me to also include the fire detection and the automatic extinguishing system. As Mr. Dominic suggested in the initial briefing, many of the fire, as per the data, as per the fire industry data, 70% of the fire is caused by electrical failures. And what we are talking about faulty or poor electrical maintenance is that initially everything is perfectly designed. Over a period of time, the electrical load is is abused by taking a lot of overrating load values, overload more than the rated values, lose connection at the termination points, temporary fixes, tapping of extra wires, faulty equipment, and aging. So, what does all of these parameters cause? It causes heat and sparks. In many cases, sparks, and all the cases heat. And heat is one of the important factor in a fire triangle. So the fire triangle, this is the fire triangle which many of you might be knowing. So fire to originate, it requires three basic components, which is oxygen, combustible material, and heat. So oxygen is always available in the atmosphere. Combustible material, any item that you know, any material that you know has a calorific value. And if you're talking about calorific value, it is combustible. So any material is combustible. So combustible material is also available. And when heat comes into the picture, it can cause a fire. So this is the reason why electrical fire is happening more frequently. So how to achieve early fire detection? By using DFA, which I will explain in the next slide. So this is a small video for the benefit of others who have not seen the automatic fire extinguishing systems. This is also known as the tubing system or sniper system, and many brand names. Call it using different names. It's an automatic fire extinguishing system. So here, this is a mock-up test panel. And we have fire. There is a fire detection tube which runs along the inside of the tube, inside the panel, and it finally comes out, and we have a pressure gauge connected to it. So we have caused a fire at two different locations inside the same panel, and we are going to show that video. So I'm just playing the video once again in case any of you missed. Here, you could have seen that there is an initial puncture over here and also a puncture over here. And you can see a small, white streak coming out from here. So this is actually where the fire has originated. And the position where the fire has originated, that particular part opens out like a nozzle, and the extinguishing agent is directly dispersed on the hot source. That is the hottest part of the tube. So here, detection and extinguishing happens instantaneously within an electrical panel. So hence the name DFA, detect, extinguish fire at origin. So wherever fire has originated, extinguishing happens over there itself. So that is this is the basic system of an automatic fire extinguishing system. So what is the benefit? It requires no power. Of course, if you want the basic fire, the fire extinguishing system requires no power. Of course, if you want a hooter, you need the power supply. But in terms of the actual detection, you don't require power. Require no manual intervention. Easy to install and maintain. Scalable with many add-ons and low operating cost. So these are all different applications where the automatic tubing systems are installed. Electrical panels, battery racks, and storage walls, etc. So how is the DFA different from others? Many of the tubing systems used welded cylinders. So these are aluminum seamless ISA marked PESO approved cylinders with a unique piston type valve with higher flow rates. So more agent is discharged through these valves. Easy to install plug-in high pressure type of fittings. No special tools are required, just plug-in type of compression fittings. Available in both direct and indirect configurations. So for the benefit of the audiences who don't know what the direct and the indirect configuration is. So this is a mock-up of a direct configuration where we have the cylinder which is filled with an extinguishing agent. Here we have the valve and a blue color tube is running inside the electrical panel or the panel we are going to protect. So the blue is indicating that the line is pressurized with nitrogen. So in case there is a fire, there is a puncture that happens on the source. So instantaneously, the pressure difference in the tube causes the valve to open and the cylinder contents are discharged directly onto the fire source. So the reduction tube ruptures at the hottest points and open like a nozzle. So that is the direct system. The indirect configuration here, in addition to that, we have a pipeline and a small tubing and a nozzle arrangement. These are specifically used for bigger electrical applications and for bigger systems. So here, again, in case of fire, the hottest part ruptures and opens like a nozzle. Here, the gas is discharged through the pipes and through the nozzle arrangement rather than the tube. So here, the tube acts as the fire detector and the tubing system acts as the extinguishing system. So this is the indirect configuration. So I'm just going, just skipping these parts, or I'll just skip through. These are different types of configurations which is available. So you have a simple system. You can integrate it with a pressure switch and an alarm system. You can integrate with a pressure switch and a pressure gauge and switch with an alarm system. You can use multiple areas for using a single system, two twin areas or bigger applications. Again, with a pressure switch feedback. Indirect system. And you can also electrically trigger these systems. So in case you are connecting this to your machinery or your electrical system, and if you have a process temperature and you want to indicate, for example, if the system needs to operate in, let's say 60 degrees, and you give a 24-volt DC command, we can still operate the system using the electrical trigger also. You can manually release the system also. So these are all the various combinations available. So the scalable, and it can also be integrated with their existing fire alarm system. So the scalable options are, almost infinite. So this is one condition where a tubing system was connected to a bigger system. We're talking about three 45 kg CO2 systems. And in case of fire detection by the tubing system, all the three cylinders will be triggered instantaneously. So protect your critical assets using automatic fire extinguishing systems. And Flooded and DFA are provided by Agni Controls, which are special application fire detectors and automatic fire extinguishing systems. And with that, I conclude my session. And thank you everyone for this opportunity and joining this webinar. And I hand over to Mr. Dominic for the Q&A.
Thank you, Selva. I'm very basic, but fundamentally it was quite strong presentation. And you touched upon the use of flame detector, Amber, which is not generally specified by the consultant. When it comes to fire detection, it's just an optical smoke detector or multi-smoke detector at their ends. But there are a lot of questions on how do you protect critical areas, including car park area, the use of the flame detector, spark detector, CO2 need to be included in the design stage itself. So today's information, what Mr. Selva has provided, I believe all the end users and the consultant who have been participating, we have wonderful participation, will start adopting these changes that what Mr. Selvakumar has recommended. So my request now is those who want to speak to the speaker can raise the hand, or you can put your question answer box we have there. We can pick up questions on those who want to talk. And also I'm very privileged to introduce Mr. Balachandar, who is the chairman of Agni Controls, also joined us today. As I said, he's one of the champion in fire industry. He is also one of the founder member of the Fire and Security Association of India. So we all joined together way back in 2000. So we started that association, and he's still highly respected gentleman. He is also present today. So I would urge him also to give, any question that comes where he can participate, he can give his wisdom to these questions. So I will take up the first questions, or I will allow, let me see how many people would raise their hand. Here, participants, here, attendees. So please put your question only in the Q&A box. I can see that a lot of people were asking for, question. They put up question in the chat box. So Deena Dayalan is asking. I'm asking him to, I'm going to unmute. Deena Dayalan, are you there? I'm allowing to talk to the speaker. Deena Dayalan, you can unmute and speak to the speaker if you are available. Or Neeraj Zahia, if you can unmute and speak to the speaker. Neeraj, you have raised your hand. I'm allowed you to speak. Okay, I will move on to Kishore Kumar. Let me see who are available. Can Kishore, you can unmute and speak to the speaker.
Yeah, I have seen the question from Mr. Kishore Kumar. Which location can we use the probe type heat detector? So
we'll go to the question answer moment. I'll just pick up those questions for you, Arun. Just a second. Yeah. I think Kishore, you are on live. You can put up your question to the speaker.
Yes, sir. I have one doubt, sir. Which location we can use to probe type heat detector, sir?
Yeah.
Yeah.
Can you the question is not very clear. The voice is not very clear. Can you repeat, please?
Which location we can use probe type heat detector, sir?
Okay. So yeah, I've seen the question. Which location we can use probe type heat detector? So probe type heat detectors are basically used in areas where you cannot use the electronics type of detector. For example, inside a solvent mixing area, you have a lot of vapors and fumes coming off. These detectors, it will the fumes and oil, those kind of areas, you'll have a lot of solvents and vapors coming off, which will mess with the electronic systems. So for those kind of applications, we will go with a purely mechanical type of heat sensor. So these detectors have no electronics inside. So number one, wherever electronics cannot be used, you can go ahead with the probe type heat detector. And the second one, any electronics cannot go beyond 90 degrees centigrade. So when you're talking about protecting a generator area, for example, or a turbine area, the ambient temperature, operating temperature, or an oven or a furnace, the ambient temperature is going to be about 120, in some cases 150. So in those kind of areas, if you want to detect a higher temperature, let's say 200 degrees centigrade, you cannot go with an electronics type of detector. So for those kind of applications, you have to go with a non-electronics type of detector. So these probe type heat detectors are suitable for higher temperature detection range. So that would be ideally the furnaces, hot, paint booths, those kind of areas where there are a lot of solvents and electronics cannot be used. These detectors can be used.
Okay, sir. Thank you.
Thank you, Selva. Hope Kishore Kumar, you got your answer right there.
Yeah,
thank you for asking this question. So I'll just remove the questions. Okay. Subrata Bera is asking, can you enlighten active and passive fire? If you want to take the question, you can take, or I can answer.
Okay, so basically passive fire protection is on more on the building side. So the construction on how the building is done, in case there is a fire happening, whether the fire can be contained in that particular area, or does your building materials allow the fire to propagate to other parts of the building. For example, fire propagates through many materials, mortars, AC ducts, HVAC ducts, cables, anyway. So for passive fire protection, we are talking about the building, the design stage of the building, what material is used, whether it will allow the flame to propagate or not. So that is basically the passive fire protection. Where active fire protection, we're talking about the fire protection systems. So your extinguisher, your fire alarm systems, your hydrant systems, all the fire protection systems which you use to fight fire or detect fire, it all comes in the active fire protection. And Mr. Dominic, if you want to add a few points, you can go ahead.
Yeah, basically the same thing what you said, active fire, anything that can detect the fire and smoke, electronic and mechanical comes into active, where you can suppress the fire. Passive is where you can contain the fire. You don't want to allow the fire to propagate more than certain hours. So maximum it can hold for 2 to 3 hours. You can contain the fire. So passive fire is not seen. You can't see the system that is there. But in active, you can see visibly when you enter into a building, you can see manual point, fire hoses, sprinkler, detector. So that's the difference between the active fire and passive fire. But in India, the active fire is what highly spoken, even our national building code. But since last 2 years, passive, when you see the fire happening across the globe, like London fire, Dubai fire, and Indian lot of fire. So passive fire is also now highly spoken. I think in the new revision in the National Building Code will have more chapter on the passive fire. So let's go to the next question. There are a good number of questions, so we'll like to run through this quickly. So what is the distance, and that is Totard Yogeshwar is asking, what is the distance and area covered by triple IR flame detector?
Okay, so the triple IR detectors, it differs from manufacturers to manufacturers. Generally, it starts from 30 meters. Some detectors have 50 meters. Some detectors have 65 meters of range along the center axis, and wide coverage area of 45 degrees. Some detectors have 60-degree cone of, 120-degree cone of vision. So single detector, some manufacturers have more than 65 meters also claimed. So yeah, the triple IR detectors are a long range detector. It is available right from 30 meters to more than 65 meters along the central optical axis. So it varies from manufacturer to manufacturer.
So Agni has what is the range?
So Agni Controls has 30 meters and 50 meter range.
So you
up to
have
50 meters. Yeah,
up to 50
meters.
meters.
Yeah.
Nice. Okay. I generally don't take anonymous questions, but anyway, I'll take this. Out of various type of flame detector, what is the type of hydrocarbon detector including open path type or point type?
Okay. So when you're talking about hydrocarbon detector, including open path type, open path is basically a gas detector. And we have not touched upon gas detectors in this particular session because gas detector itself is a very huge subject, and that is the reason why I have not included. And it's not directly fire detection; it is a fire prevention rather. So I have not included the gas detector. Open path is a gas detector, and point detectors, the flame detectors are all point type detectors.
Okay, his question continues like, what is the response time for detecting the smoldering in conveyor belt, like coal and coke and coal?
Okay, the response time. These Ember detectors are specifically designed, as I explained during my session, for fast-moving conveyors. These detectors have sensitivity selection settings. So if your conveyor speed is 2 meters per second, you can select a normal speed. If your conveyor moving is at 5 meters per second, you can increase the sensitivity to high or very high. So so pretty much you can select the sensitivity will depend on the speed of the conveyor.
So you're asking what kind of maintenance that is required for all this flame detector and Ember detector?
Well, yeah, this one point is as I told you, flame detectors are like a human eye. So for example, I'm having this spectacle. And if there is any dust or any obstruction which is blocking my spectacle, I will not be able to see beyond the spectacle. So anything which is blocking the view of the detector is a problem. So for that application, we have an external air purging provision, which will constantly keep a positive pressure on the detector's eye, so that dust will not come and sit on the detector's eye. So the maintenance point would be is that you should check for the healthiness, monitoring flickering green LED indication of the flame detectors, and you should ensure that the detectors are not, covered with any paint or anything which is obstructing the view.
Okay, I'll take the question from Pallavi Mukherjee. Can you unmute Pallavi and ask these questions? Yeah, go ahead.
Yeah.
Pallavi,
Hi. Thank you, Mr. Balchandra, and thank you, Dominic. It was a great session. Actually, since India is a very price-sensitive market, and even consultants do not recommend flame detectors. So, just wanted to know the price vis-a-vis for flame detector and smoke detector. I mean,
Okay. Yeah.
Pallavi, this
So,
is Arun Kumar Balachandran. So
Yeah.
I like to respond to this. So just for the information of the audiences, there is a point which I would like to highlight. Prior to 2005, okay, prior to 2005, flame detectors were not manufactured in India, and the usage of flame detectors were only it was there only in the oil sector, especially in the offshore sectors, where the price of the flame detectors, where one detector was costing somewhere around 2.5 to 4 lakhs. This was the price. Okay. So in 2005, Agni Controls, as part of our different industrial product development, we developed our flame detector. And we had developed it for almost 3.5 years, and we had launched the flame detectors in 2005, and as a brand in Pladet as a brand in 2008. And today, if you see, Pladet flame detectors is designed, owned by an Indian company. It is manufactured in Chennai in India, and we have some of our detectors have LPCB and CE marking from Europe. And today we are exporting to 8 countries in Europe. So from 2005, which was 100% import, India was importing flame detectors. Today we are exporting, India is exporting to 8 different countries in Europe alone, not to other Southeast Asian I'm talking, only to Europe, 8 countries we are exporting. So that is how the detector has come into picture. And as you rightly said, Indian market is a price sensitive market. And we are not competing with smoke detector. So as Selva has explained earlier, smoke detector application is a different applications. So we are only targeting applications where smoke detector cannot be used, like a paint shop. So if you take in a paint shop in before 2005, there is not even a single paint shop which had flame detectors. The only one which had installed a flame detector was General Motors in Maharashtra. That was the only paint shop that was with the flame detector. Today, if you see, even a very small paint application, even a manual painting area is now protected with the flame detector because of the price advantage which Spain bought and for that particular application, and also the knowledge of flame detectors is very well increased between our community. So this is something which I would like to inform the audience also.
Thank you, Arun.
thank you.
Pallavi, Pallavi, we can't compare the spot detector, the standard smoke detector with flame. Applications are quite different. Where flame detector can be placed, you don't need the normal smoke detector. But as I said, if you want a quick response to the spark and the flame, this only smoke detector cannot do that function. So and you can, regarding price, you can always have one-to-one discussion with Selva at a later stage. Thank you, Pallavi. Thank you for joining joining the conversation today. So, Mahesh, I'm going to unmute if you would like to talk to the speaker. Mahesh, if you can unmute, you're welcome to talk to him. Yeah, go ahead.
Good afternoon, Mr. Dominic. Good afternoon,
Good
Mr. Silva.
Yeah.
This temperature, what is the temperature at which the suppression tube rupture?
Yes. So that is, thank you very much for the question, sir. And that is one point which I failed to mention in my session. The fire sensitive tubes operate from 100 to 120 degrees Celsius. However, the temperature can be brought down using special sensors are also available where the temperature can be, brought down by 57 degrees. Your standard, standard ambient temperatures like 57, 68, 79, etc. It can be brought down. But the detection tube alone, it will be operating at 100 to 120 degrees centigrade.
You mean to say 57 is the lowest temperature at which it will rupture?
Yes.
For any...
yes.
For
automatically, yes.
Yeah. So supposing, is it possible to rupture at lower temperatures for critical areas like server cabinets and all, where the gas doesn't really matter, but the chance of fire building up to a temperature 57 is very dangerous.
Yes. So in those kind of applications.
Selva, 1 minute. Mahesh sir, so the tube itself will not burst at 57 degrees centigrade. The tube will burst only at 100 to 120 degrees centigrade. 100 to 120 degrees centigrade. But if you want the system to be operated at a lower temperature, like 57 degrees centigrade, we do have a separate add-on sensors which will be added across the tubes in different places, so which can activate at 57 degrees centigrade or even lesser. Okay, and the system will operate. Or if the add-on sensors are not activating, the tube will anyway activate at 100 to 120 degrees centigrade. So this is what Selva is also trying to explain. And I got your question regarding the server. So in servers, we can add on additional, let's say, for example, there are about 10 meters of tubing. We can add on four different critical points. We can add 4 sensors, which can activate automatically at 40 degree or 57 degrees centigrade. And it will, once it operates, again, the system will be operated. Selva, I am right?
Yes. And of course, if the server rooms are quite bigger, we don't recommend the tubing system alone. You have to go with the entire room protection with the proper fire detection and the extinguishing system. So yeah, so generally server rooms throughout the world, they go with a dedicated fire detection and an extinguishing system, sir.
Yeah. Actually, I was asking about server cabinet. Inside the cabinet.
Okay.
So inside the cabinet, I think,
yes.
Like whatever queries I asked, I think
you can have early smoke detection. We have that aspiration tube which can be integrated with the suppression inside the cabinet. So ideally, like even the small moldering that you want to detect, very early detection is the best solution that I can recommend at the moment. Okay, thank you, sir. Thank you for joining this conversation. Thank you. So I'll go to Divyaraj questions. Sir, let us know, is there a minimum distance for flame detector to be required for installation?
Yeah, there is no minimum distance. There are certain detectors, from China, and there are certain Korean detectors which will not respond when it's below 3 meters or 5 meters. But whatever flame detectors that we are operating has no minimum range. But the flame size, if it's very small or as we call it as an inverse square law. So when your flame is very small, for example, you can see a small flame nearby. The same small flame, when you go to a distance of maybe 20 or 30 meters far away, you cannot see that, that clearly. So similarly, the flooded flame detectors have no minimum range, but we are talking only about the maximum range of 30 meters or 50 meters.
Okay, I hope you got the answer. Diviraj, I go to Arunagiri is asking, what is the maximum volume that direct system can be protected? Maximum volume.
Yes, sir. So the direct system is specifically for a very closed environment. So we would not recommend to install a direct system for more than 2 to 3 cubic meter in volume. So if the volume is bigger, we will have multiple tubing systems or an indirect, multiple direct systems or an indirect system.
Okay. We have to run through a lot of questions coming in. Sanjay is asking, which detector are more preferable for printing, lamination, and warehouses location as per the norms?
Okay, so printing application, as I explained during my session, printing is a very unique challenge where the printing emits a lot of UV radiations. So for printing machineries or lamination machineries, we would recommend to use the machinery flame detector. And we have a part number called as IH225R MC, which can be used for the printing and lamination applications. And for warehouse application, you can go with the if it's not a flammable warehouse where flammable goods are stored, you can go with an ordinary UV IR flame detectors for the warehouse.
Okay. Next, which detector is the best for chemical storage room and IP ratings?
Yeah, for chemical storage room, it would come under hazardous area classification. We would recommend to go with a flame-proof UVIR flame detector or a flame-proof triple IR flame detector. That would be the best solution.
With regard to the IP rating, normally all our flame detectors, whether it's indoor safe area or explosion-proof detectors, they're all IP66. And especially for the X-proof flame detectors, when we use the proper X-proof glands and sealant, the IP66 can be converted into IP67 also.
Yeah.
And the flame-proof classifications can be used from zone 2, zone 1, zone 2, 2A, 2B, 2C, all the flame-proof areas it can be used with PESO and ATEX certifications.
Okay, move on to the next. Arunagiri is asking, when there is a fire-rated glass partition wall that obstructs the vision of a flame detector, do we need additional detector?
Yes. So glass is a unique challenge. The UV rays does not permeate through glass. So if you have an UV and IR sensor, the UV will not transfer through the glass partition. So in those kind of applications, if you don't have the option to have you cannot avoid, we recommend to use with the triple IR flame detector. And if the triple IR flame detectors can be used in areas where you have a glass partition in the middle. Alternatively, for effective fire detection capability, any obstruction would mean that you need to have an additional detector, so that even if one detector is not picking up the fire signal, the other detector would pick up.
Okay, move on to Alex Wilson is asking, what type of detector can be used in transport of transport buses? I think you must be talking about engine.
No, I assume Mr. Alex Wilson, you're talking about the transport buses which carries people or goods, but as on date they are going ahead only with the smoke detectors. But yeah, maybe smoke detector will be suitable for these kind of applications.
No, they use aerosol agent also for especially want to protect the engine and all that, so they use aerosol.
Yeah, that is the extinguishing system. We're talking about the detection part. So smoke detectors are used, because these transport buses are going into the outside atmosphere. So the better, and it's a closed environment. So I think smoke detector and a combination of heat detector may be suitable for that application.
So Guru Charan Singh is asking, any mechanism to check the detector as monthly preventive maintenance? Is any recommended check?
So there are flame detector test kits available, and as per NFPA 72 or IS 2189, periodic maintenance of the fire alarm system is mandatory. And monthly, you can do a simulation check by bypassing your extinguishing systems or anything which is hooked up to the system. You can bypass, and you can do a simulation check using the test lamps.
Well, his question is again, how can we reduce a false alarm in flame detector? He must be experienced with, I don't know which flame detector you're using. Is there any false alarm comes, Selva?
Yes. So, yeah, it depends on, as I said, the right type of application has to be used, the right type of installation angle, viewing angle, for that particular area, which type of detector is used. For example, if you're going for a printing machinery or a heater oven where there is a lot of UV and IR always around the process area, there you are prone to false alarm sources. And welding in front of the detector, very close to the proximity of the detector eye, welding is a very strong source of UV and enormous amount of heat. So heat, matlab, it's also generating a lot of IR. So welding very close, maybe less than 3 meters in front of the detector would cause the detector to generate a false alarms. So as per the manufacturer's recommendation, each manufacturer has their own recommendation. It would be to prevent welding directly in front of the detectors, positioning the detector so that it focuses the sun, because we all know that sun generates a lot of UV as well as enormous amount of heat. So the installation angle, the choice of detector, where we are going to place the detectors, all play a very crucial role. And if in case you are facing any challenges, we'll be happy to help you out, on how to install and where to install, what type of detector to install. We'll be happy to help you.
Jayakanan is asking, which detector is best for buffing ducts and scrubber? It mostly contains flammable dust.
Yes. Another type of detector which we have not touched upon is the spark detectors. And spark detectors are used for dust materials, especially flammable dust. These spark detectors are mounted inside the pneumatic ducts. I mean, or fixed on the outside of the pneumatic ducts. Seeing inside, any material passing through the pneumatic duct will be monitored by these spark detectors. So for pneumatic, ducts and other applications where you have flammable dust going on, we would recommend to use a spark detector. But if it's on the outer area, maybe the best option would be a flame detector.
Okay. Arun is asking, this fire detector is able to detect fire inside HT/LT panels. Can we use the flame or spark detector in LT?
Oh, inside the LT panel, the panel size may be very small, or if these flame detectors are basically for bigger area applications. So flame detectors may not be suitable. Maybe heat detectors can be used inside the HT and LT panels. So that would be a much more proper detector to be used inside the HT and LT panels.
Okay.
Along with smoke. Yeah.
Again, Jack is asking, I think there's a lot of demand also. Could you please explain more about triple IR and the different than normal IR or additional sensor added in it? So he wants to know more detail about triple IR.
Okay, so triple IR basically has IR sensors. Each IR sensor corresponds to a particular wavelength of flame. So we call it the IR range for a flame detector is from 3000 micrometers to 5000 micrometers. So each sensor is assigned to a particular wavelength, and the logic basically confirms. Below certain limit, it will reject as false alarm. Above certain limit, it will reject as false alarm. And between the proper bandwidth, it confirms as a as a flaming fire. So that is the basic working principle of an triple IR detector. So they basically each IR sensor is tuned to a particular wavelength of a flaming fire spectrum.
Diviraj is asking for paint booth in car showroom. Can we use heat detector for cross zoning, or what temperature that is required to detect the heat?
Yes, sir. So yeah, it is mandatory to use a cross zoning, especially if you are going to connect it to a fire extinguishing systems like water or gas-based system. It is mandatory to go for a cross zone. Heat detectors can be used for cross zoning, yes. And what temperature we required is if you are operate the ambient temperature inside the booth, the paint booth is, for example, say 40 degrees is the ambient, the worst condition would be 40 degrees. We would recommend to install at least 20 degree higher than the ambient temperature. We would recommend you to install a 60 degree or a 70 degree fixed type of heat detector. That would be more suitable.
We have done with Q&A. There are two more questions just popped up. Simadri asking flame detector inside the hydroelectric generator barrel suitably. So is the questions or is recommending? Can you take up that?
Hydroelectric generator barrel normally is circular. So the flame detector you can install, but the challenge would be that you need to have a lot of detectors to cover the entire, the circumference of the generator barrel. Generally, the hydroelectric generator barrels are octagon or hexagon or circular in shape. So the coverage would not be that, effective. You need to have multiple detectors. When you have multiple detectors, of course, the number of flame detectors are going to be quite high. So generally for the hydroelectric generator barrel, they go with a combination of smoke detectors and high temperature or heat detectors.
Vishnu Ram, you raise your hand. Is there a question to the speaker? Can you unmute and speak, please? Okay. No answer from him. Very interesting topic today. I'm also very surprised the participant has good knowledge on the special detector and the kind of interest, the kind of question that has been raised, which means people are, aware of the special detector. So today's session, I'm sure it was very informative and educative. And I want to thank Selva and also Arun for joining to complement the answer. And as I was saying, Agni Controls is the only company which I come across where they manufacture everything in-house, their engineering data sheet and the kind of quality of the installation is something that you don't come across much. They're a little above the rest of the people who give solution, and their engineering solutions are fantastic. So I've been associated with Agni Controls is more than since I would say 2000, year 2000. I've been a good friend of Mr. Balchandar, and I love to see such a webinar keep coming because they have so much of wealth of information on the early detection with suppression system. So we are coming out with the next webinar on 10th of December at 4 p.m., which is on Friday. So we're going to talk about how do we protect the critical assets, high value machineries, what kind of detection that you need to design, and what kind of suppression that you must design for this high value machinery. Again, we will come back on January 10th, 2025. That would be the first. Yes, sir.
Okay, as a conclusion, I thank you very much for your well-organized webinar and well presented. And also I thank Selvakumar, and he has been well qualified in the fire protection field and he is rightly answering. And now, just as a conclusion, knowledge sharing is a rare commodity nowadays, Dominic, especially in the fire industry. Every big multinationals are very keen to sell their products. One, I again repeat, sell their products with the catalog data sheets. They are not prepared to share their technology background and other integrity of the technologies. But today, unlike when we started about 40 years back, we don't have much source to assess such knowledges. So we have to travel Birmingham and NFPA, USA to gain some knowledges. So that much difficulties we forced to have in early before 2000. But now today, across the over a period through mobile and through webinar, you can access so many technologies, so many things are available right now. But explaining, knowledge sharing going to be one of the challenging things for us. Agni Control has taken a policy principle to share the knowledges, especially for the Indian small and big installers, engineers, beginners, and everything. Sound knowledge is the one of the only one to overcome our competition and grow forward. Technology is moving very fast way, but acknowledge the same way we have to upgrade our knowledge also. So Agni Control plan to share our whatever source and knowledges we have. We will ready to sponsor or ready to share this. With this knowledge only, the way back, as Dominic said, in 2002 we started Fire Fire Security Association of India, and try to share the knowledges. That's what we are doing now as Agni Control. I thank again Dominic for his support, and he is our long term friend also. So another 2 years we continue to share a lot of webinars. So over to Dominic. Thank you again, Dominic and Selvakumar and Arun Kumar, all my engineering team.
Thank you so much for giving that strong message to this community. We had a wonderful session, and this presentation will be shared to all those who attended and also those who missed to attend. And as I said, this knowledge series we've been doing since last 2.5 years. We have completed 289 webinars. So you can imagine the kind of knowledge that we have been spreading. 289 in the last covering. We touched almost 28,000 people with this series of webinars that we have been doing. I'm so happy that I'm so glad Agni Control also has come forward to share these knowledges to improve the lives and property, protecting lives and property, not only the commercial building and also the industrial segment. So I wish all the very best to the Agni Control and team, and I'm sure the future is yours. And Selvakumar, the young man, you long years to go, and I'm sure you will make your own mark in the industry. So all the best to Selvakumar and Arun. We look forward to see you again on 10th of January. How do we protect the expensive machineries and equipment, detect and suppress? We'll come back to you soon. You all have a great weekend. Stay safe. Look forward to see you again. Thank you so much. Bye-bye.